450 million years before the first human dream, the world was silent. No footsteps, no roars, no wings in the sky. Just a restless ocean waiting for something unthinkable to begin. And then it happened. In a geological heartbeat, Earth exploded with life. Creatures with eyes, claws, shells, armor, forms never seen before burst into existence. It was as if the planet suddenly remembered how to create beauty and danger. This was not evolution as we know it. It was a revolution. A cosmic switch flipped, and the world went from simple to spectacular. From single cells drifting in darkness to predators hunting their prey for the very first time. Imagine watching the first eyes open under an alien sea, the first creatures to see the world around them, to move, to fight, to survive. This was life's Big Bang. The Cambrian Explosion, the moment when survival became the greatest story ever told. Before we dive into the mysteries that shaped this ancient ocean of chaos and creation, make sure you subscribe, like, and share your thoughts in the comments, because what you're about to discover will change the way you see life itself. In the deep archives of time, more than 500 million years ago, Earth was unrecognizable. There were no trees, no birds, no continents bustling with life. Only a silent ocean under a pale sky. For billions of years, life had existed as little more than invisible whispers in the water, tiny, single-celled organisms drifting aimlessly without eyes to see or limbs to move. The planet itself was ancient and restless, its surface shaped by volcanoes, meteors, and the slow breathing of the seas. And then, in an almost miraculous geological instant, something extraordinary began to stir beneath the waves. In the blink of an evolutionary eye, quiet turned into a riot, a surge of creation so sudden, so dramatic, that scientists call it the Cambrian Explosion. Before this event, life's story was simple, almost too simple. The oceans were filled with tiny organisms like algae and bacteria, feeding on sunlight and chemical energy. Evolution moved at a slow, patient crawl, but around 541 million years ago, the pace changed. In a span of just a few million years, barely a heartbeat in the clock of Earth's history, the seas filled with creatures of staggering diversity. For the first time, the world saw animals with skeletons, shells, muscles, brains, and senses. It was as if nature suddenly discovered imagination. Imagine looking into those ancient waters. There, among curtains of soft sediment, new creatures swam, each one a prototype of the future. Small, worm-like beings wriggled through the seafloor mud, while spiny predators glided above them. Strange forms with multiple limbs and armored plates crawled and darted. Some had mouths lined with teeth, others bristled with sensory spines. Every few thousand years, mere moments on the geological scale, another life form appeared, more complex than the last. Transformation was not slow and peaceful. It was an evolutionary arms race. When one creature learned to move faster, another developed armor. When one evolved sharper vision, its prey grew thicker. Shells. For the first time in history, life wasn't just surviving, it was competing, and competition sparked innovation. Claws, shells, legs, eyes, every adaptation was both a weapon and a shield, driving life into a spiral of endless creativity. Scientists believe this sudden burst of life was fueled by several mysterious forces aligning at once. The planet's oxygen levels rose dramatically, giving complex metabolism the energy it needed to thrive. The chemistry of the oceans changed, allowing creatures to build hard skeletons from minerals. Even the Earth's magnetic field and climate played roles, stabilizing conditions long enough for ecosystems to flourish. And deep within the genetic code of these organisms, something remarkable happened: the evolution of Hox genes. These special genes acted like master blueprints, guiding the growth of body plans where limbs, heads, and organs would form. It was the birth of biological architecture. The Cambrian seas became laboratories of life. In one corner, Trilobites, ancestors of insects and crabs, scuttled across the seafloor with crystalline eyes. In another, Anomalocaris, a giant predator with grasping appendages, patrolled the depths like a prehistoric submarine. Jello-like creatures drifted like living lanterns. Worms with jaws of polished metal lurked in burrows, waiting for prey, and tiny chordates, primitive relatives of humans, swam timidly in the shallows, carrying the first hints of backbones. Every layer of rock from that era tells the same story: explosion, innovation, adaptation. The fossil beds of places like the Burgess Shale in Canada and Chengjiang in China are time capsules, frozen moments of this evolutionary storm. In their delicate impressions, we see the beginnings of every major animal group alive today. From those first complex bodies would come fish, reptiles, mammals, and eventually us. What makes this moment so awe-inspiring is not just its speed, but its creativity. Life went from invisible to visible, from passive to powerful. It learned to sense, to move, to protect, and to destroy. The Cambrian Explosion was not simply the birth of animals. It was the birth of awareness. For the first time, life began to look outward, to respond to the world around it, to play the eternal game of survival that still defines our planet. When we look back on this moment through the veil of 500 million years, it's almost poetic. The first eyes opened in darkness, and the world changed forever. The ocean that had once been still became a theater of movement and struggle. Every creature that has ever lived since then, every fish, every bird, every human carries the echoes of that ancient revolution in its DNA. The Cambrian Explosion wasn't just an event, it was life's declaration of power. It was the moment Earth transformed from a quiet cradle into a living, breathing masterpiece of creation. And somewhere in that surge of ancient waters, the story of everything that would one day walk, crawl, swim, or think began. Before the Cambrian period, Earth's oceans were quiet realms of simplicity, soft-bodied organisms drifting without form. Without armor, without the tools to hunt or defend. Life existed, yes, but it was fragile, microscopic, and mostly unseen. The seas were ruled by bacteria, algae, and single-celled creatures that had no real shape beyond what currents dictated. Then, suddenly, something extraordinary unfolded. It was as though evolution itself took a deep breath and began sculpting life with daring precision. Within a few million years, the oceans transformed from dull stillness into a living arena, filled with creatures that had skeletons, shells, muscles, nerves, and organs. It was the first great biological revolution, the moment life discovered complexity. Imagine standing by the shores of that ancient ocean. If such a thing were possible, the water would shimmer in strange hues, illuminated by sunlight filtering through ancient skies. Beneath the surface, the world was a frenzy of creation. Simple blobs of jelly and thread-like worms began to evolve into structured, powerful beings. The very blueprint of life was being rewritten. Creatures developed frameworks to support their bodies' internal or external skeletons made of calcium, silica, and other minerals that the oceans provided. For the first time, life was able to stand its ground. These skeletons and shells did more than protect. They became the foundation for movement and muscle. Organisms that once floated helplessly could now crawl, burrow, swim, and hunt. The rise of structure meant the rise of action. Muscles pulled against bones, limbs formed to grasp, walk, and seize. The soft veil of early life gave way to armor and agility. With strength came predation, an entirely new behavior on Earth. The hunter and the hunted appeared, and the age of peaceful drifting was gone forever. This sudden complexity is what astonishes scientists even today. For nearly 3 billion years, life had stayed simple. Then, within 20 million years, a geological instant, it became astonishingly intricate. Animals began to show symmetry, defined heads, segmented bodies, and specialized organs. Eyes emerged to perceive the world. Mouths developed to feed more efficiently. Circulatory systems carried oxygen deeper into tissues, fueling more power and speed. Every innovation sparked another. The ocean became a living experiment in design. But how could such complexity arise so quickly? One of the driving forces may have been environmental change. As oxygen levels in the oceans rose, energy became more available. This surge allowed organisms to evolve bodies that required more power to move and sustain. The chemistry of seawater also changed, providing minerals like calcium and phosphorus that organisms used to build hard structures. Suddenly, evolution had new materials to work with, and life used them brilliantly. The creation of shells and skeletons also had another effect. It preserved life in stone. Before this time, soft-bodied creatures left little trace, but now with hard parts, fossils began to form, capturing the shapes and stories of these early pioneers. This is why the Cambrian fossil record seems to appear out of nowhere. Life had not just evolved. It had learned how to leave a mark. Among the creatures of this new world were the iconic Trilobites, armored beings that scuttled across the seafloor with compound eyes that could see in ways no organism ever had before. Their shells were patterned with intricate ridges, and their bodies were divided into segments for flexibility and defense. They became one of the most successful creatures of their age, spreading across the planet's oceans. Other beings like Opabinia with its 5 eyes and strange proboscis, and Hallucigenia with its upside-down spines, seemed born from imagination rather than biology. Each was an evolutionary experiment, some successful, others vanishing forever. Inside this explosion of life, organs themselves became more advanced. The first primitive brains appeared, allowing animals to respond with purpose rather than reflex. Simple nerve cords developed into networks of thought and reaction. Digestive systems grew more efficient. Circulatory systems evolved to deliver oxygen to every cell. For the first time, life was not just surviving. It was thriving through strategy, motion, and awareness. This complexity changed the very nature of evolution. Once creatures began interacting, chasing, hiding, fighting, evolution accelerated. Predators drove prey to evolve defenses. Prey drove predators to become smarter and faster. This feedback loop of survival forged diversity we see in the fossil record. Nature became an artist working under pressure, and every adaptation was both masterpiece and necessity. From this point forward, life could never return to simplicity. The template for all future evolution was set in these Cambrian seas. Every creature that would ever walk, fly, or think would inherit this legacy of complexity, bones, muscles, senses, and instincts, all born from this first wave of biological invention. When we look back at the rocks that hold these fossils, we're not just seeing ancient creatures. We're witnessing the moment life learned how to build itself. The first architects of evolution laid the foundations for everything that followed. The Cambrian Explosion wasn't just the birth of animals, it was the moment life learned how to become magnificent. It's almost impossible to imagine a world without sight, a world where nothing sees, nothing watches, nothing hides. Yet for billions of years that was Earth. Reality, life floated in darkness, guided only by touch and chemistry, sensing the world through taste and vibration. Then, in the cold, dim waters of the early Cambrian seas, something extraordinary appeared. The first eyes, small at first, crude and simple, they were just patches of light, sensitive cells, but they were enough to change everything. In that instant, evolution discovered awareness, and the rules of life were rewritten forever. Before eyes, there was no need to hide, no reason to chase, no concept of beauty or danger. The oceans were filled with shapes that drifted, collided, and multiplied blindly. Then one organism learned to detect the faint shimmer of light filtering down through the water. That faint perception became an advantage, the difference between finding food and missing it, between safety and becoming prey. Over time, these light, sensitive patches became more sophisticated. They deepened into cups, formed lenses, and sharpened focus. From those subtle beginnings came vision, the power to see the world. With sight, evolution accelerated at a breathtaking pace. The first creatures could now perceive shapes and movement. They could spot prey before contact, avoid danger before attack, and navigate their world with purpose. The ocean that had once been an invisible battlefield suddenly burst into clarity. For the first time in history, life was looking back at life. Predators began to stalk their prey deliberately. Prey began to develop camouflage and armor. The silent balance of the seas erupted into a living, visual drama, one that would define every future ecosystem on Earth. Trilobites were among the first to possess true eyes. Their complex, faceted lenses were built from crystal, tiny calcite formations that captured light and focused it onto nerve cells. These creatures could detect movement and patterns, even see the shimmer of their surroundings with astonishing precision. Imagine a world seen through hundreds of crystal facets, where every flicker of motion in the water meant life or death. That's how the trilobites survived and thrived for millions of years. But sight didn't belong to predators alone. The prey fought back in ingenious ways. Some evolved mirror, like shells, to confuse attackers. Others learned to burrow into sand or mimic the color of the seafloor. The battle for survival became a masterpiece of adaptation. Where sight existed, deception followed. Where hunters saw better, the hunted learned to disappear. Evolution had created its first arms race. One fought not with claws and teeth alone, but with perception and illusion. Scientists believe that the rise of vision triggered this explosion of complexity. When one creature developed eyes, others had to adapt or perish. Suddenly, the ability to blend in, move faster, or protect oneself became essential. Eyes didn't just help creatures see, they forced everything around them to change. In this way, the appearance of sight reshaped the entire biosphere. It also changed the structure of the ocean itself. Before the Cambrian, the seafloor was home to slow, passive life. After the rise of vision, Creatures moved upward, chasing light into open waters. The ocean filled with movement, darting, swimming, swirling life competing for food, light, and dominance. The water became a theater of motion and color, a living storm of creation. From a biological perspective, the eye is one of evolution's greatest achievements. Some developed simple pinhole types, others complex compound structures. Each design told a different story. Some creatures saw in blurry silhouettes, others in stunning mosaics. The very act of seeing created new possibilities: depth, distance, recognition, and choice. The world was no longer a mystery of touch and instinct. It had become a visible stage where behavior and intelligence could evolve. Think about what that means. Every act of vision today, of a bird spotting its prey, a lion watching from the grass, a human gazing at the stars, can trace its origin back to that moment in the Cambrian seas. The first spark of light recognition gave birth to the senses that now define all higher life. The eyes of humans, complex and emotional, are descendants of that ancient miracle. Every blink carries echoes of that dawn, when the first creatures learned to see, and in doing so, learned to act with purpose. Vision also gave rise to something deeper: awareness. To see was to know there was something else beyond oneself. The first eyes marked the birth of perception, and with it, the birth of curiosity, fear, and strategy. The oceans had changed forever. Life could now plan, chase, escape. It could choose. When we imagine the Cambrian seas today, we picture them alive with light and movement, shimmering bodies gliding through ancient waters, eyes glinting with new intelligence. It's humbling to realize that the simple ability to see transformed the destiny of every creature that would come after. The appearance of vision didn't just illuminate the ocean, it illuminated evolution itself. The first eyes opened, and the world was never dark again. The ocean had never known fear before the Cambrian. For billions of years, life had existed in quiet cycles, cells dividing, drifting, feeding in slow, chemical calm. There was no hunt, no chase, no strategy, but then something in the deep began to stir. As creatures evolved sight, strength, and speed, an entirely new concept entered existence: the predator, and with it came the first arms race in the history of life, a war between hunter and hunted that would shape every living being to come. It was a conflict not fought with weapons forged by hand, but by evolution itself. Every tooth, every claw, every shell was a story of survival written into flesh and bone. In those early Cambrian seas, danger began to move with purpose. The first predators were unlike anything the planet had seen before. They were swift, muscular, and armed with innovations that made them the terrors of their time. One of the most formidable was Anomalocaris, a creature that could grow up to a meter long, enormous for its era. Its body rippled with power, its segmented tail propelling it through the water like a living torpedo. Two spiny appendages extended from its head, perfect for grasping and crushing prey, and its circular mouth, lined with hard, tooth-like plates, was an evolutionary masterpiece of efficiency and destruction. For the soft, bodied creatures of the seafloor, Anomalocaris was an unstoppable shadow, but evolution never allows one side to win for long. The prey adapted. Some creatures began to grow armor, mineralized shells that could withstand bites and impacts. Others burrowed deep into the sediment, hiding from the eyes of their hunters. Some evolved spines so sharp that swallowing them could mean death. The predators' hunger became the prey's reason to transform, and in turn, each new defense forced predators to become smarter, faster, and stronger. This escalating spiral, predator against prey, became the engine of evolution. It was the first great biological arms race, and it changed the shape of life forever. The diversity that arose from this struggle was breathtaking. Creatures developed new ways to move: wriggling, swimming, crawling, grasping. Muscles evolved to give speed and precision. Mouths became more sophisticated, designed to tear, crush, or scrape. Some animals developed pincers and claws, while others grew flexible appendages to sense the world or manipulate objects. Each generation of predator inspired innovation in its prey, and vice versa. The seafloor became a battleground of ingenuity, where every adaptation meant another chance to live one more day. The development of hard body parts also had an unintended side effect. It gave the world fossils. Before the Cambrian Explosion, soft-bodied creatures rarely left behind any trace. But now, shells, spines, and skeletons preserve the history of this evolutionary war in exquisite detail. Every fossil from this time tells a story of adaptation, of defense and attack, of survival against impossible odds. What we see in stone today are the echoes of that eternal struggle, the first evidence of Nature's endless cycle of creation and destruction, this newfound predation didn't just shape physical forms, it changed behavior. For the first time, creatures learned to hide, to stalk, to flee, and to ambush. Intelligence began to evolve as a weapon. The ability to anticipate, to react, to outthink an enemy became as valuable as claws or armor. This was not just evolution of the body, it was the birth of strategy. In those waters, speed meant survival, senses sharpened, reflexes refined. The first nervous systems capable of rapid responses emerged, allowing creatures to react instantly to movement or vibration. Eyes grew larger and more complex, enabling predators to spot their targets from farther away. Prey developed sensitivity to light and motion, fleeing at the first shimmer of danger. Life was learning, adapting faster than ever before. What's remarkable is how that ancient struggle still defines us today. Every predator stalking a forest, every fish darting from danger, every heartbeat that races in fear, all of it traces back to that primordial war in the Cambrian oceans. The predator-prey relationship didn't just shape evolution, it became evolution. It forged the instincts, reflexes, and survival mechanisms that drive all animals, even humans. In a sense, the Cambrian seas were the cradle of conflict, the birthplace of fear and aggression, but they were also the birthplace of resilience and innovation. Without the constant push and pull between hunter and hunted, evolution might have remained slow and passive. Instead, it became a storm. A relentless creative force that sculpted every living thing that followed. Picture that ancient seafloor, shimmering in the blue light, alive with movement and tension. Predators glide in search of prey, armored forms crawl cautiously through the mud, shadows twist and dart. Every creature alive is both danger and target, every moment a gamble between life and death. Out of that chaos, the modern world was born. The instincts that drive survival today, the chase, the fear, the fight, were written into the code of life during this age. The Cambrian arms race was not just a battle of creatures, it was evolution's way of ensuring that life would never again be still. Even now, more than 500 million years later, scientists still struggle to answer one haunting question. What triggered the Cambrian explosion? How did the world go from a planet of tiny, simple microbes to a living ocean filled with eyes, armor, teeth, and movement, all within the blink of geological time? The fossils tell us what happened, but not why. The cause remains one of the greatest unsolved mysteries in Earth's history, a puzzle carved into stone, written in DNA, and whispered through the layers of ancient seabeds. Some believe it began with the breath of the planet itself, oxygen. Before the Cambrian, Earth's atmosphere and oceans contained far less oxygen than today. Life was simple because it had to be. There wasn't enough energy in the environment to support complex metabolism. But then, something changed. Over millions of years, cyanobacteria, tiny photosynthetic organisms flooded the oceans with oxygen through the process of photosynthesis. The air thickened with the gas that would one day sustain us, and the seas became supercharged with energy. With that, evolution had fuel. Cells could now power more complex bodies, muscles, nervous systems, movement. Oxygen was not just a gas, it was the spark that ignited the engine of complexity. But oxygen alone can't explain the sudden burst of life. Another theory points to Earth's shifting climate. Before the Cambrian explosion, the planet may have endured a global freeze known as Snowball Earth. When ice covered nearly the entire surface, for millions of years, life was trapped beneath frozen seas, surviving in small refuges near hydrothermal vents. When the ice finally melted, the flood of nutrients from land washed into the oceans, creating a chemical banquet for life. It was a planetary reset and a perfect opportunity for evolution to start fresh. The melting unleashed not just warmth, but chaos, an unstable, nutrient-rich environment that pushed organisms to adapt rapidly or vanish. In the wake of that thaw, the Cambrian seas bloomed with possibility. Some scientists suggest that the trigger came from within life itself, a genetic revolution. During this period, organisms developed powerful new genetic tools called Hox genes. These genes act like master architects, controlling how and where body parts form during development. They determine where a head appears, how many limbs a creature has, and how its body segments are arranged. Before Hox genes, life was simple and repetitive. Afterward, it became infinitely customizable. It's as if nature suddenly discovered the blueprint for diversity, the ability to build endless forms from a shared foundation. Once that genetic key evolved, the door to complexity swung wide open, but perhaps no single cause can explain it all. The Cambrian explosion may have been the result of many forces, Colliding geological, chemical, biological, and cosmic shifts in the Earth's crust may have increased volcanic activity, releasing minerals and nutrients into the oceans. Ocean chemistry may have stabilized, allowing for the construction of shells and skeletons. The magnetic field may have strengthened, protecting life from deadly solar radiation. Each factor alone might not have been enough. Together, they created a perfect storm, the ultimate conditions for life to evolve at lightning speed. The mystery deepens when we consider timing. Why did complexity wait so long? Life had existed for nearly 3 billion years before this event. That's an eternity of silence before the sudden chorus of creation. Some researchers believe that once a certain level of biological innovation was reached, perhaps the evolution of cells that could cooperate, communicate, and specialize, a chain reaction began. One adaptation made another possible, and another after that, until evolution snowballed uncontrollably. And still, the question lingers, was this explosion inevitable? If we could rewind the clock and let evolution play out again, would it happen the same way? Would eyes, claws, and skeletons still emerge? Or was the Cambrian explosion a one-time miracle, a fragile alignment of chance and chaos that could never repeat? Even with modern science, we can only glimpse pieces of the truth. Fossils from sites like the Burgess Shale and Chengjiang reveal astonishing detail, soft-bodied creatures frozen in rock, their delicate forms preserved across 500 million years. Yet for every fossil we find, countless others are lost forever. The record is incomplete, the story fragmented. What we see is just a faint reflection of the greatest evolutionary event in history. Perhaps that's part of its power, its mystery. The Cambrian explosion is a reminder that even with all our knowledge, the origins of complexity remain beyond full comprehension. It was a moment when the universe seemed to hold its breath and then exhale life in all its glory, a time when evolution leapt, not crept. The causes may be hidden in the depths of time, but their consequences are everywhere. Every movement of a fish, every flutter of a bird's wing, every heartbeat in a human chest, all of it traces back to that mysterious spark. The Cambrian explosion was more than an event, it was a turning point written into the very code of existence, a riddle that continues to echo through the DNA of every living thing. Every creature that breathes, crawls, swims, or dreams carries within its cells a story that began over 541 million years ago during the Cambrian explosion. It was there, in those alien seas, that life first discovered complexity. Every limb, every organ, every nerve that exists today can trace its lineage back to that ancient moment when the blueprint of all animal life was first drawn. The ancestors of all living things, fish, reptiles, mammals, even humans were born from the waves of that explosion, the evolutionary dawn that turned the planet into a living masterpiece. Imagine those first beings, their shapes strange and new. Some looked like segmented worms with spines, others were armored and bristling with appendages. They were the prototypes of everything to come. Deep in those murky waters swam Decay, a small, slender creature that looked unremarkable at first glance. Yet hidden within its soft body lay something extraordinary, a flexible rod of cartilage running along its back. That simple structure, the notochord, was the first step toward the vertebral column, the spine. From that single innovation would one day arise fish, amphibians, reptiles, birds, and humans. Decay was one of the first members of the phylum Chordata, the great lineage that would give rise to all vertebrates. In that tiny swimmer lived the spark of everything that would one day walk upon the land or look to the stars. From the genetic chaos of the Cambrian came organization, systems within systems. Neural networks began to form, connecting sensory input to motion, creating the first whispers of coordination and control. Muscles pulled against skeletons, hearts or their early equivalents began circulating nutrients, and digestive tracts became specialized. The leap from simplicity to sophistication had been made, and it set the direction for all life that would follow. Evolution had found its rhythm, and that rhythm would never stop. As time moved forward, the descendants of those early creatures diversified. Some became faster, more agile, developing fins that cut through the ocean like blades. Others stayed close to the seafloor, their bodies flattening to hide from predators. Some experimented with shells, others with speed. Nature was running thousands of experiments at once, sculpting designs that would echo across eternity. Every shape we see today, every bone, every joint, every symmetry began as one of those evolutionary trials beneath the Cambrian waves. What makes this realization so profound is that it connects us to a lineage stretching beyond imagination. The hands that hold tools, the eyes that see colors, the brains that wonder about the universe, all of these are the echoes of adaptations forged in that ancient crucible. The first vertebrates learned to sense their environment and respond with purpose. Over millions of years, they grew more advanced, developing skulls, jaws, and fins. Eventually, some of their descendants would crawl from the water, breathing air for the first time, and claim the land as their new frontier. From those brave pioneers came reptiles, dinosaurs, mammals, and finally, humans. Every fossil from that age is like a page torn from the book of creation. The Cambrian Explosion didn't just give birth to animals, it gave birth to the story of life's persistence. From that point onward, evolution was no longer a slow drift, it was an unstoppable march. Life diversified into endless forms, driven by the same instincts that began in the ancient seas: to move, to feed, to survive. Connection between us and those early ancestors is not symbolic, it's biological. The genetic instructions that guided their growth still hum inside our cells today. The same molecular machinery that shaped their bodies now shapes ours. The same oxygen that filled their oceans fills our lungs. In every heartbeat, there's a rhythm that began there, in the first creatures that dared to move with purpose. So when we look at the fossil beds of the Cambrian, the Trilobites, the Anomalocaris, the tiny decay, we aren't just seeing the past, we're looking at family, we're looking at the roots of everything that has ever lived. The Cambrian Explosion was not the end of a story, it was the beginning of our story. If you haven't yet explored our previous topic, the mysterious trigger, what sparked the Cambrian Explosion, you're missing a key chapter in this journey through deep time. Check the link in the bio to dive into that mind-blowing mystery and uncover the secrets behind life's greatest leap. Now, prepare for what comes next, because in the following episode, we step beyond the Cambrian seas into an entirely new world. Next topic, the Age of Giants. Sea monsters before dinosaurs, before land was tamed and the dinosaurs ruled, the oceans were the true kingdoms of terror. In the next episode, we'll explore the rise of colossal marine predators that ruled the deep, the first rulers of Earth's ancient seas. Stay curious, stay amazed, and keep following the story of life before humans, because the ocean still remembers where we came from.